Uh, Good evening, everybody. My name is Maxim, and I'm a software engineer at Igalia company, and today I'm going to present you our project, which is called Chromium's Way to Wayland. First of all, I'm going to talk about Igalia company. I will give some information about us. Then I will proceed with the goals and the motivations behind the project. I will give some background, give the developments overview, what we have done, what we are doing now, what we're going to do next, and of course I will do some demonstration. So Igalia is a private worker-owned company. We run a consultancy business in open source area, and we are based in Galicia, Spain, in a city called Coruña. It's in the northwest of Spain. And currently we're 62 employees around the globe. Half of us work from Spain and another half work remotely from other parts of the world. And the main areas that we work on are Chromium, Blink, WebKit, Server. We're also a member of W3C community, and we contribute to web standards. We do work on compilers, JavaScript engines like V8 and JavaScript core runtime, language runtime. Also, we do multimedia stuff like GStreamer multimedia toolkit, kernel development, networking, graphics like method drivers, accessibility, virtualization, and cloud. And on the picture, you can see our Web Engines Hackfest that we host every year, and this one was hosted last year in October. So this map shows how we are distributed. Some of us work from Europe, Spain, Finland, Denmark, UK, also from USA, Brazil, Chile, and South Korea. So what's the goal behind the project? The goal is to be able to run Chromium natively on any Wayland-based system. So if there is a system which runs Wayland, there should be no limitations or impedances to run Chromium on it. And what motivated us to do that project is that Wayland is actually quite a mature solution nowadays. And we think it has better design in a sense of security, better design stack support, and what is more, it's a, well, nowadays a good solution to the X windowing system. Also, there's a quite big demand from different industries like automotive or mobile and desktop. And to name a few, those are from the automotive side, for example, automotive grade Linux, Genevi, Volvo. From the mobile side, there are a Finnish company called Jolla, Tizen, as well as Qt Toolkit, GDK, and on desktop side, there are Ubuntu, Debian, which started to ship Wayland. As the background, so where the Ozone Wayland project comes from? So first of all, it was done by Intel company, 01.org organization, and it used back at the time Ozone project, which was and is still part of the Chromium project. And it's an abstraction layer underneath the OR toolkit to construct the accelerated surfaces. And the backends it supported were DRI, which became DRM, utilizing the GBM for the Chrome OS operating system. So Wayland took this approach, this project, and started to develop Wayland support of the trunk for Linux operating system. And to give you a minimalistic view how desktop integration looked like for the stock Chromium, I have a diagram here. So there is a browser process and renderer process which has some kind of JavaScript, HTML, stuff computation, and the sandbox GPU process. Inside the browser process, there's a so-called desktop integration, which has toolkits and graphics platform-related stuff like X11 bits and Windows. So they took that approach and added Ozone Wayland sibling inside the desktop integration. On the other side, there was a browser GPU process which had a Wayland connection, and everything was communicating using old IPC APIs. So we can treat this project quite successful because there was a good community adoption. Many companies took it to ship in their project as well. But eventually it came to the maintenance mode in December 2015. And back at the time, the Chromium version was M49, and today is M66, which is 17 miles gap. So it means that that lacks of some security, bugs fixings, all other bugs fixings, and some of the functionality losses. So in the meanwhile, the ozone layer became to something else, and it supported and it get new backends like X11 and Wayland. But was the problem solved? No, it wasn't, because the original desktop integration, which was taken, didn't comply with the foreseen desktop integration in Google. So, as you remember, this is the approach that Intel took, but now there is another design called mass Linux integration for desktop. So, in the desktop integration, there is now our mass platform independent integration, which communicates with a new service called a UI service using the module APIs, which are the newer IPC APIs in the Chromium browser. Inside that, we can see the GPU service hosted by the UI service, and the ozone layer is now underneath the UI service, and it has Wayland and X11 backends. And to say more, nowadays there's another work happening in Chromium, so-called visual service, which is about to have GL, heat testing, and compositing in a different process. And it will also host a GPU in another process as well, which will give additional 15% of performance. So Ozone project evolved to the abstraction layer underneath the UI service instead. And it supported such backends as GRM, X11, and Wayland, but for the Chrome OS. For the Linux, we still needed to do something else to be able to run it just out of the box. So how we proceed with the project? So in September 2016, we brought the Wayland backend to the tip of the trunk and started experimenting so that Ozone is not Chrome OS. On the picture, you can see how it looked like. So at the bottom, there is a Chrome OS specific widget, which is not acceptable for the Linux version of Chromium. We also added documentation for the Ozone and set up a build bot in the upstream. Then, in the cooperation with Google, we came up with two expressions. The first one was internal window mode, which is about having Chromium for Chrome OS, which runs a window manager inside and the screen manager. And that window had only one accelerated widget, and then it was Aura, which drew different windows inside that one accelerated widget. So user didn't interact with the host operating system window as itself. And then there is another expression called external window mode. It's the mode when there is no internal window manager, and there are different accelerated widgets created for each new Chrome window. Let it be, for example, tooltips, menus, and any other Chromium windows. And now user manipulates the accelerated widgets via the host operating system window to maximize them, minimize them, resize, drag, or full screen. In internal window mode is the internal window manager, which does all this stuff. And of course, in external window mode, there is no such a thing as a screen manager. So to give you an overview how it looked like in the beginning, here's a demo how it ran on the Renesas M3 board back at the time in 2016. So as you can see, the bouncy balls demo is not smooth enough, and it lacks of performance. Here's also scrolling, which is not that smooth enough. And of course, the work still needed to be continued. We also forked the meta browser and implemented our meta browser recipe so that any Yocto-based system could build the Chromium and use it there. So what we needed to do in order to bring external middle mode? So we needed to modify internal middle mode so that it created for each new top-level window an accelerated widget. And we also needed to extend the MAS, so-called module UI service, and Ozone in order to support external middle mode. And we needed to ensure that there were no major functionality losses or performance losses compared to the stock Chromium. To start with, we began with MAS demo. So this is the demo which actually exercised the UI service. So we needed to extend it in such a way so that it created different windows with different accelerated widgets and draw some content inside that. We also needed to rework the internal window mode code assumptions. For example, in Chrome OS, there is one relationship of the display on the UI service side and the display on the Aura side. For the external window mode, the display on the Aura side actually represented a physical display, but the display on the UI side represented an actual window, Chromium window or menu window or any other window related to Chromium. So the relation became from one-to-one to one-to-many. We also extended MOS and Ozone to support external window mode, as I previously said. And what we needed to do there is to properly handle, for example, bounds and route the events from Ozone to up to the Aura. Also, we made it possible to run Chromium with the existing --MAS flag so that UI service would came up. We also added XDJ version 6 support because before that it was only XDJ version 5 support. Keyboard events, auto-repeating, mouse cursors, because before that it was the internal window manager which did the stuff. Also added to support for the touch events. This patch was provided by our friends from Calabra. We added multiple window support. We started to use built-in window decorations instead of the host-provided ones. Implemented window closing support, because before that was the window manager, internal window manager, which actually did the stuff. We added menus, widgets, and tooltips support and allowed user to interact with the windows, like maximizing them, minimizing, restoring, making them full screen, and so on. We also needed to change the ownership model of some objects, for example, representing the states of the windows on the UI side, UI service side. We also implemented keyboard like IME service integration. We did some slightly custom window tree hierarchy so that representations of the window on the Aura side would comply with the representation of the windows on the UI service side. We also needed to rework the access policy so that the clients on the Aura side would access only the specific widgets or windows it is allowed to access. And of course, we work on stability and hardness of our implementation and made the content shell to be run with MAS on Linux. And what's the status of the project today? I will show you the video how it runs on Debian with GNOME shell on Wayland. So let's have a better quality. So as you can see, this is MAS with Ozone platform Wayland backend. And it's actually version 66, the most latest one by this day. It supports many tabs. Here's actually HTML5 test, and we score 526% points out of 555, and all the features which are supported in the development branch in the TOT are supported by our browser as well. And we score around 60 FPS in the WebGL demos, so everything is hardware and GPU accelerated. So you can see two windows working at the same time. And you can ask why I'm showing it to you, because it's the same Chromium. Well, I want to say that it's actually the same Chromium, but it uses another design, and it uses a Wayland backend, which was impossible before that. Here is also another demo with X11 backend, but I'm not going to present it here. The idea is that while we were working on extending UI service to be run on external window mode, we also added support to run both Wayland and X11 backends, which means that you do not need to get another Chromium binary for that one. You will just need one binary, and using the Ozone platform flag, you will specify which backend you are going to use. And if you remember, there was another video which I showed previously, how it ran on the Renesas Aircar M3 board using the bouncy balls. So nowadays, it's pretty smooth, given that nowadays Renesas M3 board runs only on 2 cores, because other 4 cores are blocked, and that's under development. So a few words about the project itself. Currently, the project is hosted on GitHub in the downstream repository. We have a well-defined contribution policy, like we do peer reviews on each commit. Also, we have an internal build board running our existing tests. For example, the services unit tests, like some UI-related tests, Ozone unit tests, browser tests, content browser tests, and we have 98% of the pass rate. Also, we run content unit tests. And why we need internal build board is that because we want to ensure that whenever we implement new feature or do any changes, there are no regressions. We also have well-defined weekly rebasing strategy, and we continuously clean our GitHub history. For example, when we implement a new feature and we need to have some kind of change for that one, we commit a new fix-up. And whenever we do rebasing, we squash all the fix-ups, so the history keeps clean. And when we upstream patches to the upstream repositories, we add do not carry forward flags, so that next week when we do rebasing, we do not add this commit, which might have been changed in the upstream while we were upstreaming it, because a Chromium community might have requested to change the patch a bit. Also, we do periodic sync-ups with Google so that we comply with their plans. If you are interested in more design and more deep, you can follow the documentation in the Google Docs. And this presentation is available on the FOSDEM website, so that you can follow from there. So what's left to do in that project? We still need to implement drag and drop support, and we lack of clipboard support between Chromium and host. For example, you can do copy pasting inside the Chromium window, but not outside that one. Also, we still lack multi-screen support, and we do not support non-English layouts. Also, we continuously ensure that there are no feature losses and major performance penalties if we compare to the stock Chromium. Also, we do integration inside automotive grade Linux, and this job is started and done by IoT, but whenever they request our help, we provide it to them. Also, we plan to release desktop installers in the sense of DEB or RPM packages. And one of the important things is to continue upstreaming our projects to the tip of the trunk. Also, we are planning to enable more tests in the upstream build bot along with upstreaming. And as I previously said, we still need to decouple mass from visual service so that the GPU process will be run not as a thread inside the UI service, but as a separate process. Thank you for your attention. The project is done by Galia and sponsored by Renesas. Whether you have any questions, you can contact me, Maxim, or my colleague Antonio from Igalia.